SpaceFlight Insider traveled out to Promontory, Utah to cover the test firing of NASA's Qualification Motor 1. To gain a better understanding of the dynamics involved in this highly important test, SpaceFlight Insider interviewed Orbital ATK's Jeremy Redden.
These boosters provide the kick needed to get off the launch pad. They are an incredible source of thrust. They provide 3.6 million pounds of thrust each. That's a vacuum thrust. They also weigh about 1.6 million pounds each. As a combined system, they provide the capability to take our astronauts, take our payloads into deep space, enabling the missions of going to Mars, perhaps the moon, an asteroid, the intermediate destinations that we need really to enable our pioneering of deep space.
4, 3, 2, 1, fire.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.
It's incredibly exciting to think about the point in time which we are in history right now. We're enabling missions to Mars. There's kids right now that are 8 to 12 years old who will be the first astronauts that will go to Mars. To be able to participate in the vehicle that will take them there is an engineer's dream. It's a dream for me.
SpaceFlight Insider spoke with Orbital ATK's Gordy Russell to find out more about the booster's history, as well as some of the other projects that the company is working on to help inspire the next generation of rocket engineers.
So the shuttle program was ending. We weren't sure what the future was. We went from maintaining a great program of space travel to not knowing what are we going to be doing next. And slowly but surely things started to be put into place, and we now have the Space Launch System, or SLS program. And we're starting to see that future. We're hitting milestones. We're starting to test the things that we're designing and getting things prepared for an actual flight. As in the next few years, we'll be launching astronauts again from American soil. We have a student launch program called NASA Student Launch. It's a competition that students from universities across the country are involved in, and as well as high school. And these students have to go through everything we have to go through for a flight, a design, testing, everything to make sure that they're good to launch just a little rocket. But we also give them experiments they have to do that support directly the new program. And the excitement that they had that they were being able to design brand new things in their world that could help support an actual government flight system that can take astronauts back into space was amazing. And that excitement, I saw it even go down the lower level. The U.S. Space and Rocket Center is here in Huntsville, Alabama, where I'm located, and students that are in grade school, they started to see that they got to do new missions as they're learning and planning to do and to work as a team, and what kind of opportunities they have in the future, that they're not just going to be watching things in the past, videos from the past, but we actually get to see astronauts go back into space and further than they've ever been before, and it's great to be around that excitement. These students are truly learning to be rocket scientists. They are doing everything that we have to do in our day-to-day jobs. They start out from initial preliminary design reviews to actual critical design reviews, and they start design and building their rockets. And even before they're allowed to test, they have to go through all the same paperwork and flight readiness reviews that we have to do on a day-to-day basis.
Russell also had a surprising fact about the demographic that came out in the lead for this competition.
It's amazing to see that these high school level students many times outperform the university level, as they're putting their heart and soul into what they're doing because they're excited about new and better space travel.
Incredible day as we stand around, watch this vehicle take off into space, enabling the missions that I don't think we've even dreamed about yet, all the missions that it will perform. This is our future, this is the heritage that we're going to leave behind for our kids to talk about.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire! +5.